Hello everyone. How are you guys doing today? Hi Tom, hi Fatima. I am doing fine, alhamdulillah. Thank you for asking. How are you guys doing, everyone? I'm also doing fine, Queenie. Thank you. Thank you for asking. Give me 1 second. Let me try to log in from my other desktop. Oh, 863, 863, 5773, 86. Okay. Yeah, we have only 3 more classes, and then our class will be over. So we have the rest of chapter 12 and chapter 5 to cover, and we have chapter 15. So my plan for today is to finish chapter 12 and go to chapter 15. Chapter 15 will take probably 2 days, and then today we're going to do half. On next class we're going to do another half, and then it will do little chapter 5, and next week Wednesday we'll have a review. Okay. Any question from anyone? Any comments? Complaint? Yeah, last class recording. Thank you for reminding me. I totally forgot to upload that. I'll do it after this class, inshallah. You're welcome. And about our class on Monday, so we are going to have our Monday class online. So I'm so sorry to have it online. And so I won't go to Hunter before the final. So if any of you want to see your exam too, please come to Baruch. I'll give you your exam here. Otherwise, you have to wait till the final exam to get your exam too. Our final exam will be on December 18th, which is exactly 2 weeks from today. From 5:20 to 7:20 in our classroom. Okay. So just because you have your second exam, it doesn't mean we are done with this class. Nope, we are not. We still have many things to cover for the final exam. So without delay, let me start rest of chapter 12. So in chapter 12, oh, by the way, don't forget to do homework. Your last day of homework, I don't remember when, but it's very soon. So make sure you finish everything before the last day of submission. Okay. Okay, so I don't remember how many questions we have from this section, this topic. in your homework, one or two or more, but we're almost we did half of chapter 12, and in another half we have only a few questions to talk about. What is the last day of the homework? I will see. And then since we'll do chapter 5 homework, chapter 5 Monday, so yes, I will extend the homework. What happened to my screen? Yeah. Okay, so if you remember, chapter 12 talks about independency between December 10. Let's see, December 10 is next Monday. So yeah, I'm gonna extend the due date till December 13. Officially, December 13 is last day of our class, so I'm gonna make the due date to 13 for chapter 5. Okay, so chapter 12 talks about testing whether to categorical variable are independent or not. So in order to test that, we use chi-square test, and the first portion was chi-square test of goodness of fit test, and today we're going to talk about the test of independency. So we have two sample with two variable. So we want to see whether they're independent or not. So the difference between the goodness of fit test and independency test is that in goodness of fit test, we worked with only one variable, and we did what? We completed the table based on the proportion given to us. And we said, well, our expected count is proportion times the sample size. So proportion for each category times the total sample size gives us the expected count. And then to find the test statistic, we subtracted the expected from observed, squared the quantity so that we work with a positive number, and then we divide by the expected. Now in here, we're going to do very similar calculation. But instead of having one sample, we have two samples to work with. So we are going to do same calculation twice. So here we need our expected cell count has a different formula. Previously, it was n times the proportion, but this time it's number of row total times column total, and it divided by the grand total. Grand total means the total sample size. So row total give us categories, column total give us sample, and then when you multiply them together, we divide it by the total of the total. And in here, our degree of freedom is number of row minus 1 times number of column minus 1. And there are two conditions to verify, just like the previous one. Either we are working with a random sample or the representative of a population sample that is a representative of the population, and all the expected count must be at least 5. Actually, not at least, it has to be more than 5. So if any of the expected count is less than 5, then you cannot use chi-square test for that. Okay, so one example. A school surveyed 145 students about their favorite type of extracurricular activity. Their responses are shown in the table below. is there a significant relationship between the gender and favorite type of extracurricular activity based on the data we have? So we want to see whether we have a relationship between gender and their extracurricular activity. So they gave us number of boys and number of girls for each category. We have 3 categories. Some people like to play game. Some people like to watch TV. Some people like to read books. So 3 categories and 2 types of sample. One is boys, one is female. So first thing we need to do is we're going to find total for each of them. Total row, total column. So let's go row wise. If you add number of games, we have 5 plus 1, 6. 4 plus 2, 6. The next one, we have 3 plus 3, 6. 4 plus 1, 5. And then the last one, we have 23. So I added all the rows. Now, if you add the row total, we have 6 plus 6, 12, 13, 14, 15. 6 plus 5, 11, 12, 13, 14. We have grand total 145. And they are telling us that we have total 145. So this is like a big N, like grand total, like total people we surveyed. Now, if you go column wise, 5 plus 3 is 8. We have 1, 2, 3, 4, 48 here. And then we have 3 plus 3, 6 plus 1, 7. 4 plus 4, 8 plus 1, 9. Now, if you add this quantity, it must add up to this number. If it doesn't, that means something is wrong with the calculation. So 8 plus 7, 15. 9 plus 4, 14. Yep, it missed. So step 1, find the total. Total row and total column. Now, the chi-square statistic is very similar to the first part. We need to know total of the total. So we have expected, first we need to count, and then we are going to subtract that from the observed, square the quantity divided by expected. Now, this expected has formula, this one. It says multiply the row total by the column total, divide that by the grand total. So we have 2 column wise and 3 row wise quantities. So one of the easier way to find the test statistic here is to combine them. For example, we have boys and game, make it one quantity, boys and game. So for boys and game, we have 25 people. So observed quantity for boys who like game is 25. Now girls for the game. Girls for the game, we have 41. The final exam is December 18, which is exactly 2 weeks from today at 5:20 p.m. in our classroom. I'm going to send an email about that later. Okay, so what I was saying here is that convert this table into one column. I mean, not one column, 2 columns. One column with name and the other column with observed quantities. So game has 2 choices, boys or girls. So for boys it's 25, for girls it's 41. Now TV also has 2 categories. One is boys, one is girl. So boys TV 13, girls TV 43. So you have 2 choices. Either you go row column or you can go column row. It's up to you. The main thing is you're going to take one row and one column. So let me list all of this. So in my example, I went column row. So I took boys, and for each boys we have 3 categories. Either they like to play game, or they like to watch TV, or they like to read book. So for boys, game is 25, TV is 13, and books is 10. Now, then I'm going to the girl. For girls, we have the same thing. Either they play game, or they watch TV, or they read book. So for girls, it's game, TV, or books. So it's up to you which way you want to organize them, but you're gonna get the same results anyway, so it doesn't matter. Now, based on how you organize, you're going to multiply the number differently. So in my case, my row is, I need to multiply the rows or column actually. I need to multiply the column for boys times the row for the game. So boys column is this, row for the game is this. We need to multiply them. 48 times 66. Whatever we have, we always divide by the total number, 145. So all of these we are going to divide by 145. The numerator will be different based on your categories and gender, but the denominator is same for everyone. We're dividing everyone by 145. Now the next one, I need to do total boys times total TV. So total boys is 48, and total TV this time is 56. The next one is total boys times total books. So again, total boys is 48, total books is 23. So you multiply them and then divide by total. Then we have, what's the book? The girls. So for girls, we have total girl times total game. So total girl is 97. So I'm going to have 397 because I have girls. And then number of game is 66. Number of TV is 56. And number of books is 23. Whatever we get, that's the expected count. Once we get that quantity, we need to divide that, we need to subtract that from the observed. So, can all of you start from anywhere? Do one of them and give me the answer, please. Try one from here and then write the answer on the chat box. You can write like boys game is this, or boys book is this. Well, actually this is easy. Let me do this. 1, 2, 3, 4, 5, 6. So pick one and shoot me the answer, please. Thank you, Yusuf. The first one is 21 point. Let's say we are keeping 2-digit. I don't have much space. So 85. Okay, tau is 18.54. Anyone else? Elise, which one? Which one you did? Third one? Okay, thank you. 7.61. Thank you, Salma. 44.15. Anyone else? Thank you, Fatima. 37.46. And the last one. Thank you, Lazy. Sorry. Why keep making mistake in your name? Thank you, Salma. 15.39. Great. So we have all the expected. And now we are going to find, let me change the color again. Observed minus expected. So observed is 25. So 25 minus 21.85. We squared the quantity and we divided by expected, which is 21.85. The next one, our observed is 13. So 13 minus 18.54, squared that, divided by 18.54. So I'm writing this down. You guys do the calculation. 10 minus 7.61 squared divided by 7.61. Then we have our observed is 41. So 41 minus 44.15 with the square, and then 44.15. Next we have observed 43. So 43 minus 37.46 divided by 37.46. Let's take 96. It's 46. Lastly, we have 13. So 13 minus 15.39 squared divided by 15.39. Okay. Now, what do we have for all of this? So take any one of these, do the calculation, and shoot me the answer. Which one? First one? Thank you. 0.454. Second one, 1.66. Thank you. Come on, guys. The faster you do it, the faster you're going to complete this. Third one is 3.93. Thank you, Yusuf. Fourth one is 0.22. Let me do 225. Thank you. The last one is 0.37. And we have the fifth one. Other one is 0.75. Okay. 0.75. And the fifth one is 0.818. Great. Now our chi-square statistic is sum of all these numbers. So add all of these, whatever we get, that is our statistic. Chi-square statistic is the sum of observed minus expected square. What did I write? Expected square divided by expected. In other words, 0.454 plus 1.66 plus 0.37. If you add all of these, what do you get? 4.279. Great. Thank you. If any of you guys get them something different, please let me know. Now we need to know what is our degree of freedom, because we need to find critical value. So degree of freedom for the independent test is row minus 1 times column minus 1. So we have 1, 2, 3 rows and 1, 2, 2 column. So 3 minus 1, 2 minus 1. That gives us 2 times 1, which is 2. And they want us to use alpha 0.01. So our alpha is 0.01. So we go to chi-square table. Let me go to the table. Chi-square, the last one. So you have full degree of freedom. I forgot. So 2 degree of freedom 0.01. 2 degree of freedom 0.01. 2 degree of freedom is here. Yeah. 0.01 is here. So 2.01 is here. 9.21. 2 degree of freedom or 5.01. 9.21. So our chi-square critical is 9.21. So we found critical is bigger than statistic. Do you reject or fail to reject the null? Do you remember? How do you make the decision? Our critical value is bigger than statistic. When critical value is bigger than statistic, what do you do? Fail. Good job. We fail to reject the null. What does that mean? It means null hypothesis is saying that there is no difference between them. Okay, there is no, not difference, sorry, there is no connection between gender and their favorite type of activities. Okay, so there is no relationship between the gender and the favorite type of activities. We failed to reject that. So we don't have enough evidence to support that claim that there is a relationship between them. We don't know. With this data set, we cannot say that they have a relationship. We fail to prove that we have a relationship. So there is no relationship between the two things we just compared. Okay, so we do not have enough evidence to say that there is a relationship between them. So we are satisfied with the conclusion is that there is no relationship between them. Clear? Any question, comments? Anything? So this method is easier to find your test statistic. However, if you look at your homework, then homework has a question where they want you to fill out a table like this. So this table is same thing as what we did in the first one. The difference here is that if you observe, each one has 2 columns. For expected count, we have 2 columns. For our last column here, observed minus expected, we had 1 column here, but they have 2 columns here. So either you can do using my first method, or you can use 2 columns and then calculate that. So personally, I found working with 2 columns is harder. So I do not like this method. But if you like it, if you're comfortable using this method, feel free to use that. Otherwise, I would suggest to use this type of table. Instead of working with 2 columns, you have more rows to work with. Okay? With this, we're done in chapter 12. Oh, and we can work with p-values, but I'm not showing you the p-value. P-value is hard to get using table. So always critical values, if you're working with some tables, paper tables, then critical value is easier to work with. Okay, any question, comments, concern, complaint, anything? Wonderful. So we are done in chapter 12. If you guys pass this class, you don't have to worry about this table if you don't take any more statistic class. However, if you fail this class, that means you have to take this class again. And if you take it again, next time, there is a high probability of seeing this question in the final exam. But in our final exam, you will not see this, okay? I'm being nice and I'm telling you that it will not be in the final exam. But it will be in the next semester final. There's a high possibility. Because this is one of the most favored question by the department. Okay. Now we are going to ANOVA. Instead of going to chapter 5, I'm going to ANOVA so that you can practice with ANOVA during weekend. No. Also chapter 15, what you are starting now, it will be in the final exam. So for the final exam, I suggest you to study all of my questions in my exam 1 and exam 2. Study the review sheet and this ANOVA. And there will be one more extra question, which I'm going to go over during our review. If you study this, you'll be fine for the final exam. Oh, not only exam, sorry, my exam review sheet, chapter 15, and one more question. Okay? Yeah, I'll do it after class. Actually, to be honest, I'm not done with the slide yet. Okay, so once I'm done, I'm going to post it. But my plan is to go over only a few questions, probably 2. If you have time, then 3. And then we'll be done with chapter 15. So the difference between chapter 15 and chapter 12 is that in chapter 12, we compared 2 variables, okay, like gender and their preferences. So these are 2 variables. We worked with 2 variables, we compared them, and we see if they're independent or not. Now, in chapter 15, it's called Analysis of Variance, in short, ANOVA. So in ANOVA, we look at more than one samples, not only variable, but also samples. So an analysis of variance test whether statistically significant difference exists between more than 2 samples. So we are comparing 2 samples, not categories, but 2 completely different samples. For this purpose, the mean and the variance sense of the respective groups are compared with one another. So let's say we have 2 samples. So we compare the mean for both samples and the variances for both samples. In contrast to the t-test, which tests whether there is a difference between 2 samples, the ANOVA test whether there is a difference between more than 2 groups. So with the t-test, we can work with 2 samples, but if you are working with more than 2, you cannot use t-test anymore. So for more than 2, ANOVA is better. And depending on what we have different types of ANOVA. For example, we have 1 factor ANOVA. When you're working with 1 factor, but we have more samples, more than 2 samples to work with based on 1 factor. Or we have 2 factors ANOVA. It means we have 2 things to look at, and for each one, we have more than 2 samples. 1 factor ANOVA with repeated measurements and 2 factors ANOVA with repeated measurements. Good news, we are going to do only the first one in this class. 1 variable with more than 2 samples. One-way ANOVA is a type of statistical test that compares the variance in the group means within a sample, while considering only 1 independent variable or factor. It compares 3 or more than 3 categorical groups to establish whether there is a difference between them. Within each group, there should be 3 or more observations, and the means of the samples are compared. It is a hypothesis-based test, meaning that it aims to evaluate multiple mutually exclusive theories about our data. Just like t-test, z-test, chi-square test, ANOVA also has some assumptions to be fulfilled in order to be performed. The first one is normality. Each sample is taken from a normal distributed population. The sample we are working with, we want them to be normal. Sample independence. Each sample has been drawn independently of the other samples. It means the observations we have, they're independent of one another. Variance equality. The population variance has to be equal for all sample, all group. Dependent variables should be continuous, like intervals or something that is increments. Means, when comparing population means, the samples are independent random samples. When comparing treatment means, experimental units are assigned at random to treatments. Now, some notations. ANOVA has more notations, much more notations than what we have seen so far. K is number of populations or treatment being compared. In other words, number of groups. Okay. Population or treatment. So we have one population, two population, and then whatever population you're working with, we name them up to K. Now, for the population or treatment mean, we use mu1, mu2 up to mu k. And then for variance, it's sigma 1 square, sigma 2 square, up to sigma k square. Now for sample size, n1, n2, small n1, small n2, up to small nk. Sample mean is x bar 1, x bar 2, up to x bar k. And sample variance is s square. So s1 square, s2 square, blah, blah, blah. Now big N is called grand total. So grand total is number of all small total. So let's say you have 3 groups of sample to work with, and group 1 has 3 people, group 2 has 5 people, group 3 has, let's say, 7 people. So big N is sum of all of them. And T is the grand total. So big N is the total number of observations. And big T is the grand total. It's the sum of all N observations in the dataset. So it's N1, X1 bar, N2, X2 bar, blah, blah, blah. And then X double bar is big T divided by big N, which represents the grand mean. Good news for now, since we don't have much time, so you don't have to remember all these details. The main thing I realized that you need to know is this. The big N is sum of all the samples, sample size. And you definitely need to know what is K. And these are just some notation we used before, so this should be easy. Now, these are definition we need to know. Treatment sum of squares. We represent that by SS big T smaller. It's a measure of differences among the sample mean. So it's the difference of the sample mean. Now we have error sum of square, which is SSE. It's a measure of variability within the K sample. So it's like variance. Mean square. It's the sum of squares divided by its degree of freedom. Sum of squares divided by degree of freedom. And then we have 2 types of degree of freedom. One is treatment degree of freedom, and one is error degree of freedom. The treatment degree of freedom is number of groups minus 1, and error degree of freedom is the total observation. This is our total observation. Total observation minus groups. If you add both of them, both degree of freedom, then we get total total sum of total, what is called, let's see, total degree of freedom. So total degree of freedom is degree of freedom 1 plus degree of freedom 2 Degree of freedom 1 means is a degree of freedom for the treatment, and it means it's the number of group minus 1. Degree of freedom 2 is degree of freedom error. It's the total observation minus number of group. And if you add both degree of freedom, we get total degree of freedom. So all of these, they look horrible, I know. But you need to know this. Okay, so I'm highlighting what important things we need to know. Degree of freedom definition for 1 and 2, and SSTR is a definition, so it means difference of the sample mean, and we use that divided by degree of freedom 1 to get mean square of treatments, MSTR. The SSE is the measure of variability. We divide that by degree of freedom 2 to get mean square of error. Why do we care? Because we need total sum of square is the sum of these two quantities. Either you can find it using this formula if you have a raw data, but if you don't have a raw data, then if you just have a table of information, then total sum of square is SSTR plus SSE. It means treatment sum of square plus error sum of squares. Once you write down all the definitions, then we can go ahead and do a hypothesis test. So in order to do a hypothesis test, we need to use another distribution. It's called F distribution. Now, let me skip this because these are not that important. These are just details. So in order to do the F distribution, what we do is first we state null hypothesis and alternative hypothesis. So null hypothesis says that there is no difference between each mean. So all means are equal there. There is no difference between them. Alternative hypothesis is there is some difference. One treatment could be better than other treatment. So there is some difference between them. So we proceed with stating null and alternative hypothesis. Then we find a test statistic. Our test statistic is MSTR divided by MSE. So remember, MSTR and MSE, you need to know MSTR is here and MSE is here. Once you find the test statistic, then you have you need to find p-value or critical value. If you want to find critical value, then you need degree of freedom. And the 2F table has two types of degree of freedom. One degree of freedom is on the upper side. Another degree of freedom is column wise. So one of them is row wise, one of them is column wise, and we have alpha level. So we, depending on what is our alpha and what are the two degree of freedom we have, we go there, and then whatever we have, that's the number we get for the critical value. And just like before, if the test statistic, the positive test statistic is bigger than the critical, we reject the null, otherwise we fail to reject. And then based on the hypothesis test, we make the conclusion whether we have enough evidence to support the claim or to don't have enough evidence to support the claim. Now comes the interesting part, the fun part. So this is the table you should know. Okay, you should write down on your cheat sheet. Oh, for the final exam, you're allowed to use two-sided cheat sheet. So in this table, whatever we talked about so far is summarized here. It's saying that for degree of freedom, we have two types. One is degree of freedom treatment. The other one is degree of freedom of error. Then for the sum of square, we have SSTR and SSE. It means sum of square of the treatment and sum of square of the error. The next column is mean square. So mean square of the treatment and mean square of the error. Now the F test is mean square of the treatment divided by mean square of the error. Whatever we get, that's the F statistic. Now for the total column, if you add degree of freedom 1 and degree of freedom 2, you get total degree of freedom, which is same as total number of observation minus 1. Now total sum of square is the sum of these two. If you add them, you get the total. Now what will be in the exam is something like this. They will give you a scenario to work with, and they will give you some of the data in the table. Your goal is to find out the rest of the entries based on the given entries, and then do a F test on it. Okay. Which table? The F table or this table in the example? Which table you're talking about? Tau. Both of them will be given. I'll show the F table. This is the F table. I'll show in details later. So in here we have degree of freedom on the top, and we have degree of freedom on the bottom, and we have degree of freedom from 1 to 30, and then by 10 or 20 or 30. Okay. So one of them is up to 1 to 10, and the other degree of freedom is many things. I know there are so many tables. So you need to know when to use which table. But anyway, here comes the fun part. We are going to do a treasure hunt. Okay. Some of them are given. Find out based on the given one what's the missing piece. Now let's do this together. For the treatment, we are given sum of square and mean of square. Now we need to know what's the degree of freedom for the treatment. Now, if you observe, let me erase all of this. If you observe here, it says mean sum of treatment is sum square of treatment divided by degree of freedom. See here, this is our degree of freedom 1. So can we find this degree of freedom 1, which is treatment? Do you see any way we can find this quantity? Do you have enough information to find this quantity? What do you think? Just by observing all these symbols. So this is degree of freedom for the treatment. So this quantity is SSTR. This is MSTR. And this one is degree of freedom for error. And this is our F. Do you guys see anything here? So we know MSTR is SSTR divided by degree of freedom for the TR. Now, they already gave us MSTR and SSTR, right? So they gave us this quantity and this quantity. So if you substitute them, our MSTR is 0.708, SSTR is 2.214. We need to know what is the degree of freedom for the treatment. Can you find it? Can you solve for degree of freedom for the treatment? This is algebra, guys. If you don't want to use your brain, too bad. Algebraically, if you want to solve for this, the easy thing is just switch them and you get the answer. So our degree of freedom for the treatment is 2.214 divided by 0.708. Thank you, guys. We had 3.13, but degree of freedom should be a whole number. So we take it as 3. So if we know degree of freedom 1 and degree of freedom 2, can we find the total? Total is what? Degree of freedom treatment plus degree of freedom error. If we add them, we get the total, which is 22. So see, we could fill out column 1 easily. Now, next thing, which one you think is easier to work with? Our next entry here is SSE, and this is MSE. And our F is MSTR over MSE. So which one is easier now to find, SSE or MSE? And you also need to know SSTR total. You're dumb. It's true, MSE. How can you find MSE? Using what? Do you have enough information to find MSE? Wonderful. We know the F distribution has a formula MSTR over MSE. Now, they give us a F distribution. Our F is 0.75. They also gave us MSTR, which is 0.708. So we can easily find out what is MSE. Again, it's algebra. All you have to do is switch their position. So our MSE will be 0.708 divided by 0.75. How much you'll get from here? Come on, come on, come on, come on. Yes, in real life, yes. But for this exam, no. So this is 0.944. Thank you. So we found 3 of them already. Now we need only 2 more, SSE and SS total. Now, which one is easier to find? SSE or SS total? SSE. Good. So how can you find SSE? Any idea? Let me actually tell you one more information. Oh, actually, yeah. Our information is here. See, SSE is here. So if you know MSC and degree of freedom 2, you need SSE. So they told us MSE is SSE over degree of freedom for error. So they're telling us our MSE is 0.944 because we already found that. We have no idea what is our SSE, but we do know our degree of freedom for error is 20. Yeah, this time you have to multiply. So since you're solving for SSE, we need to multiply both sides by 20, so they cancel out. So that tells us our SSE is 0.944 times 20, which is 18.88. So 18.88. Since we know both SSTR and SSE, that means we can find the SS total. It's SS treatment plus SS of the error. So 2.214 plus 18.88. That should give us 21 something, right? 9012. Right? So see, we found everything. So in the final exam, you're gonna do this. Complete the table first. So it's like a treasure hunt. Something is given, based on that, find out the next step. Say go one map to another map. Once you're done, then you're going to do hypothesis test. So do I have a hypothesis test? No, I don't have a hypothesis test, but let me make up one. Let's say we want to test at alpha level 0.1. Yeah, suppose we have some type of things to observe, okay? And we want to test whether those samples, they're independent or not. So we are testing our hypothesis using alpha 0.1. We need degree of freedom. So we have degree of freedom of treatment, and we have degree of freedom of the error. Degree of freedom of the treatment is 3 and 20. And we have alpha level 0.1. So we can find F critical. They already gave us F stat. We didn't have to find it here, but if they didn't give us F critical, F stat is MSTR divided by MST. Okay. So they gave us, this thing is 0.75. So we want to see the critical value is more than this or less than this. So in order to find the critical value, we go to the F table, 3 and 20. So F table, degree of freedom 3 with alpha 0.1. So see what degree of freedom, one of them, the 1 is smaller than 2. So this is one of them. Highlight 3. For some reason I cannot highlight. Anyway, so actually let me pull this up with annotator. Oh man, I pulled out the wrong one. F table. Okay, so degree of freedom 1 is 3 and the other one is 20. So we have to go down, keep going down here. So degree of freedom 2 is 20 and degree of freedom 1 is 3. And we are looking at 0.1. So 0.1 is this number. On the left, we have degree of freedom 2. On the top, we have degree of freedom 1. Wherever they intersect, we have all of these alpha level. So alpha 0.1, 0.05, 0.01, and 0.001. 4 types of alpha is given together. So you need to look at your appropriate alpha. In our case, it's 0.1. So for 0.1, we have 2.38. So our F critical is 2.38. Now, when you compare statistic with critical, we found that critical is bigger than statistic. So we fail to reject the null. Since we failed to reject the null, so we don't have enough evidence to say that they are not independent. They means whatever sample you're working with. They're not independent. So in your exam, you'll have more specific scenario. Here, I don't have a specific scenario. I just have the table. So in our next class, we are going to do one example with more details, which will be similar to the exam question. But that's all you have to do. An incomplete table will be given to you. Based on the information they give you, you need to complete this table and then find the critical value from the table and compare them. So we don't have any homework on chapter 15. What I would suggest is to search on your own about one or a ANOVA test. See if you have some examples you can work on where we have something like this. And I'll see if I can get more examples from anywhere. Okay, so actually you're done in chapter 15. I gave you all the important information you need. In our next class, we're going to do more example of ANOVA, and then we're going to do chapter 5. And Wednesday, we're going to do a review for the final exam. And our final exam will be exactly 2 weeks from today. Any question from anyone before we leave? Any comments? Any concern? Any complaint? Nothing?
I don't have any questions.
Okay. So have a good night. Have a good weekend. see you all again on Monday, but it will be online. Okay. Thank you.
Have a
Fatima,
good
you have a
weekend.
question?
Yes, I wanted to know what, we were emailing about this, but what day or what time are you available so I can come to pick up my exam?
Let me know your time. I'll be Baruch every day, almost every day. So let me know when it's convenient for you.
Okay, so probably be end of this week or like beginning of next week.
No problem.
Okay, thank
Let me
you.
know your time when when you think you'll be coming. So if I have a class,
Okay.
tell you that I have a class that time.
Okay, I will. Thank you.
Bye, everyone.